Good morning everyone, and welcome to today's product tutorial on STIX, Secure Search and Information Exchange. I'm Perry Smith and I'm part of the Myriad Technologies team, and I'll be giving the presentation today introducing STIX specifically around the digital node network. So who is Myriad and who is STIX? Myriad's an Australian-based company. We're a Microsoft Gold partner, and we focus on large enterprise challenges, in particular defense and national security challenges, where you've got a number of specific requirements and needs, and that's what STIX is all about, and that's where Myriad focuses its time and its energy. STIX is Secure Search and Information Exchange. It's a product manufactured that helps solve a large number of problems in challenging networks and related spaces. Where did STIX come from, and what is our experience? So essentially we started work back in 2011 with the Land Network Integration Centre, a new division at that stage of Australian Army. Since then we've worked across land, air, sea and joint scenarios, and also interoperability scenarios between Australia and France. We focus very heavily in the last few years on the cloud technologies and bringing warfighter digitization to life, making it a reality, not just in the core networks, but also in the deployed networks. And to us, deployed is a lot more than just putting a bunch of kit, IT kit, out into a particular location to operate. And we'll go into further details of that and why that's important, particularly in the data space, which is where we have spent a lot of our time. In the last few years, we focused very heavily on big data and artificial intelligence and how to light those things up and to make best practical use of them in DDIL type environments. Our experience ranges across Australian Navy, Army, Air Force Joint. We have got exercises going with Finnish Defence. We've got trials happening in Sweden. We are a part of an evaluation in Norway, and we've got active projects underway integrating our technology into the BlackNet technology in German defence. All of this adds up to, we've learned some things, and we've learned how we believe that the digital node network as a reenvisaging of the way we treat traditional networks can help solve some of the core problems at the heart of the military. So what is STIX? Secure Search and Information Exchange. Won a number of awards over the years, and in essence, it is a C4 ISR support and interoperability platform. It's made up of a number of components and layers, and we'll cover them off in more detail as we go through. So if you looked at those capabilities collectively, what is a STIX node? It is the total collection of those capabilities, and that includes the STIX services, the tools, the applications, and the platform elements. So STIX is not a single thing, and you can't think of it as a single thing. The sum of the parts is most definitely greater than the whole. So what are those parts? What are those things that make up STIX? So if we start with thinking about abstracting away compute and store, how do we not worry about whether it's an R720 Dell machine or an HCI converged piece of IT kit? What if we treat it as the platform layer can be treated as any x86 based platform? That is the first element that the STIX services and tools at the bottom of this diagram are introducing you to. It's the abstraction layer away from a particular implementation. And that includes the abstraction away from a specific cloud implementation. So whilst we fully support on-premises and we support full cloud, as in Azure full cloud, we also support hybrid and disconnected scenarios on cloud and on on-premise kit. And that's done through the magic of this bottom layer. Working up through the technology sets, we have a using layer, and these are the technologies that we use to deliver an outcome. So what are those technologies? Collaboration services, think of that as deployable SharePoint on steroids. So it is SharePoint in the core, we're running underpinning that with SQL, but it has a large number of enhancements to make it specifically usable, both in terms of the technology and working across disconnected environments, but also in terms of the user services and the way they are done to make them a repeatable pattern across your entire enterprise. Build once, leverage many times is the core element of the collaboration capability. The Big Data Engine is a product called MediaFlux, and we integrate MediaFlux to provide us with those large data scenarios which are becoming more and more common to military and all other areas of our commercial life. Large data, think of ISR data ingestion. We can ingest data at up to 35 terabytes an hour, and in a clustered scenario, we can do 70 terabytes an hour. We can't just ingest it, we can also aggregate it, process it, and make it available for data dissemination in a number of ways. And we'll go through those as we work through the different scenarios. We have a powerful analytics and reporting capability, fundamentally powered by Power BI, but also working within these various scenarios and disconnected environments. The cross-domain component is developed by Real Network Solutions, and its label is a Stargate unit. The Stargate unit can either be a physical unit or it can be a software unit, and it can be both at the same time. Fundamentally, what it enables is a cross-domain transfer of information, and it can sit across a diode to give you guaranteed physical one-way transfers. It doesn't just do that, it also provides a number of node-to-node protections. We have a very powerful forms and workflow automation engine to allow for data capture, to allow for data processing and data orchestration. Data federation is all about the ability to federate the information. Having information at a forward headquarters or being able to process it locally is somewhat useful. Being able to aggregate and disseminate that information in a meaningful way to various different standards is infinitely more powerful from a military perspective. And data federation is core to understanding what the STIX node network is all about. On the screen, we're seeing a single node. In a moment, we'll cover what does that mean when multiple nodes are brought together to operate as a node network. Robotic process automation is a component built into the capability set to allow interfacing to older technologies that don't provide modern support. Federated search is the ability to function in two modes. We can either replicate the indexes to do disconnected search and federation of information across multiple nodes, or we can aggregate that across single nodes to provide a federated search of what's available across your node network. Cognitive services is specifically around machine learning and artificial intelligence, and it's making those services available to you in a disconnected scenario, but also in a way that is low cost and full effect. So cognitive services can do things like information translation, like language translation. It can do things like voice translation, and it has a number of capabilities that we embed into STIX platform as core capabilities. So that's the technology layer. But what does that provide us? If you think about what capability sets you then get, you can start with data management. Data management is fundamental to what we're talking about. Command through voice, control through data. Commanding through voice, yes, use your comms networks and use the voice commands and everything else. But the poor cousin has been the control through data to date. STIX changes that, and we believe that data of the future will be king to supporting powerful decision making, which is the second box you can see. We provide the capability to put the right information to the right people in the right point in your network at the right time. So if you have an RFI at a forward operating base and you need that RFI to be posted backwards, and you need that to be an automatic process, not waiting on a number of manual elements in it, that is the sort of thing where we can specifically aid decision support. We can also aid it through being able to present the right information through the right applications and through the right dashboards at the right time. These things add up to an operational capability. We can use Stix node to directly support the mission. So to stand up a Stix node, as an example, from bare metal through to full operating node, everything you see on the screen here, is about 2 hours to run. If you already have an instance of Stix, the bare physical kit there, then you can stand up an operating mission in about 90 seconds. Compare this to the way you currently run your missions and the information and capabilities you currently have. A real life scenario in another country, this used to take them 3 months of planning, and even when they had that, the actual mission instantiation of the technology sets would take many, many days, up to a couple of weeks. We've got that down to 2 hours and 3 minutes. The next two boxes deal with battle management and intelligence. And what's important to understand here is that Stix does not do battle management and it does not do intelligence per se. What it does do is provide the ability to host and house those applications to allow them to do what they do in a managed C4 ISR environment. So what you can start to see is the Stix node is a C4 ISR support element enabling the other functions to operate. Your battle management, be it SID-aware or be whatever it is, can still do what it does. Stix augments and enhances the ability to manage that information and integrate it into other information that you have. Similarly for intelligence. Interoperability is something Stix does natively, and it does it very well. Interoperability does not just mean technical interoperability. We also mean military interoperability with compliance to STANAG standards. We also mean compliance to corporate governance, i.e. your ISM compliance requirements. Interoperability to us is the combination of all of those things, and Stix provides capabilities to greatly enhance and standardize the way interoperability is functioning. And lastly, at the provide set, we have the analytics, the ability to analyze that information and provide meaningful elements that need to be distributed between one node and another node. At the top layer, so what can that deliver? From a Stix perspective, these are just patterns. And these patterns that we've described here are illustrative. They're by no means exclusive to these ones, and you don't have to have all of these elements either. You may already have a force planning and design component. Maybe it's the latest S/4HANA element that does that. So what Stix can do is directly interface to that and provide you an integrated platform to allow that to function as it should. If you don't have one of those, then you most certainly can use the modules in Stix that deliver these capabilities. Mission support, mission planning, and information dissemination are core capabilities. Stix also provides the ability to define what we call schemas, and these can be platform schemas and application schemas, and I'll go into those a little more. So we haven't forgotten with the digital node network that it's not just about having those nodes, it is also about the sustainment management over the top of those nodes in their operating environments. So let's take an example. So Stix node network. Let's take this typical operating example as a military operating example and look at what are the data flows that are needed to be supported from this. On the screen, we're showing you three primary patterns of data management and data distribution that Stix fully supports. On the left, let's look at the first example. You might have source data. That could be information from your enterprise systems, be they SAP, Oracle, whatever that system is. You may have technical publication information. This could be the SOPs. It could be the actual technical breakdown of all of the parts on a particular ship and how to maintain them and how to order them and all the other bits and pieces. It could be your machine learning models. It could also be your mission planning and execution inputs. From a Stix perspective, these are a pattern and they all operate exactly the same. There is a technical interface to consume that information, and we allow the ability to ingest into a node and distribute throughout the node network. As you see here, we have 5 nodes on the illustration, and these nodes may be placed in, on the left-hand side there, for example, a fleet headquarters. That fleet headquarters could be running on Azure, it could be running on a Stack Hub, it could be running on any compute and store. In this case, we're showing what it might look like in a cloud-based scenario. The middle 2 nodes, as you can see, have got a DDIL network bearer sitting in between. That DDIL network bearer might be Ninshaw, it might be a 3G connection, it might be a SATCOM connection. From our perspective and the node network point of view, it does not matter. It could even be a swivel chair between the left-hand node and the middle nodes. STIX makes no presumption, and the design of the digital node network specifically works over any bearer network that you have. So what might that do once that information reaches the middle layers over this node network? The first thing we need to consider from a data perspective and a digital node network perspective is that we cannot have trusts going between what's sitting on that ship and what's sitting on the shore. Those trusts fundamentally need to be done away with, and what that means is that your traditional network connections need to be rethought about how they function and how they operate. Because the implicit definition of what happens in all of the current implementations is that there is a trust, either an AD trust or some other form of trust, PKI trust, between that deployed vessel or that deployed asset and the core network. STIX separates that concern and fundamentally operates each of those nodes in a zero trust operation. So there is no physical technical trust between any of these nodes, the T1 on the left, the 2 T2s in the middle, or the T3s at the right-hand side. Because there are no trusts, we can also operate 100% offline. Because there are no trusts, we can also run different crypto on each implementation of a node within the node network. So what we've now done is removed the security hole and the cyber hole that existed when you had to share trusts across those different nodes. And there are a number of different systems in defense that all rely on those trusts. STIX and the digital node network specifically removes that as a limitation. Now what that also means is that if these are running from a different crypto perspective, then information captured out here on this vessel in the middle at the top T2 node, it may be capturing information from imagery, it may be capturing UAV streams, whatever that data is, will be coming in and can be analyzed now on that local node. There's enough compute and store on many of the vessels to allow that to happen. But how do you then get that information in a standardized, searchable, secure way from that vessel to where else it needs to be? And this is the next core element and the next fundamental element of what the STIX node network does. As we capture ISR data feeds, let's take for an example the sensor we could be talking about, for example, out here on this plane on the right-hand side. That could be the sensor data of the engines. This is the second pattern. Now that sensor data as it comes in across different assets, as a UAV, a ship, a plane, a vehicle, whatever that ISR sensor happens to be, a digital rifle as an example. That sensor data needs to be ingested, standardized into a common sensor platform. Without the common sensor platform, you just have more data. And you can only process that data on the edge because you can't distribute that data and you can't manage that data and you can't aggregate it. Again, this is the core function of the STIX Big Data module, is to provide that common sensor platform and to standardize that data to allow it to be distributed where it needs to be. A typical example, we noticed from the at the edge analysis of the sensor stream coming off that plane that the right-hand engine is going to fail in 2 weeks' time. So we're doing predictive analysis using AI and the ML libraries to predict that it's going to fail. There are people that need to be made aware of that in different elements and different ranges of areas of this entire chain of information. This chain of information might include logistics. It might include replacement aircraft. A whole range of different areas need to be made aware that there is an event looming that needs to be dealt with. The third pattern of information that's critical to understand is that these different areas will capture mission data as well. Now that mission data, as it comes in, needs to be processed from a data point of view exactly the same. We need to ingest it, standardize it, distribute it, and we need to do an additional layer. We need to have targeted automation of what that information has realized and done. So in the middle of sticks, there are a bunch of ways that we can define smart, intelligent rules, and those rules allow that information to be targeted to the right audience in the right dashboards of the right nodes throughout this environment. Keep in mind, zero trust between these nodes. Auditing, other controls are all still in place. Full accreditation can still be done, but we are now distributing the data in a cyber-safe method. And we're also producing actionable data and actionable commands that can be presented to the right people to make those decisions. So what you see on the screen here is the fundamental consideration of a digital node network. Now, from a technology perspective, the design elements, when you look at DDIL network bearers between each of these nodes, when you look at the fact that you still need information exchange regardless of what that bearer is, that bearer might be a line of sight RF link between 2 points. And we need to be able to target that replication of information very effectively so that flash information is sent flash. And if I've got a ship coming into an area of operation and it needs to be MCOM or it needs to be running silent, it still needs to be able to share, if it can, flash information with another ship coming out of an area of operation. And there are many scenarios like that where those technical scenarios exist and STIX fully supports them. So what differentiates STIX from a military point of view? And this is what we start to see happen. We don't believe you need to transform military, but you do need to transition it to enable it to work more effectively. Currently, a lot of the sequential information that happens and the processes that happen are done locally and sequentially, all the way from a planning activity involving Joint Operations Command out to 3 Brigade or whoever it happens to be, manually standing up a mission, manually executing that mission, and then manually repatriating data and sending information back to those various different headquarters. But what if in a digital node network, data was centric and the information sharing managed with a data-centric perspective, still with man-in-the-middle controls, still with security and cyber protections? What you would start to see is this ability to support, in the middle there, multiple different taxonomies, full oligonomy management. You'll start to see knowledge flow in through the way that the military functions and operates. Now be clear, the transition 2 does not change what the military does. It changes the way the data is managed through the digital node network. And in this way, we start to light up the data. We make it, more data is available earlier in a more consumable format. And what that means is you will have superior decision making because you will have superior information to your adversary. And at the end of the day, that's what it's all about. Getting superior information as quickly as possible in as targeted a manner as possible to the right people in the right places of the digital node network. Now, I will just spend a moment explaining what this is about. Some of the methods that we introduce and we bring with the digital node network is not just the network itself. It's the ability to roll out agile-based methods of delivering more capability in an accredited way using pattern and risk-based accreditation as opposed to what has been traditionally done. Now, the digital node network doesn't rely on this method, but what this allows you to do is introduce DevOps into a military scenario, and it allows you to do it in a pattern and risk-based way, in an accreditable way, and in a standard structured way. So what you see here in this little box here is what we call schemas. And each digital node is controlled and managed by a schema. And the schema works at all the way from the underpinning compute and store layer all the way up to the application layer, regardless of whether the application is sitting within the node or sitting out to the side of the node. So even applications that are not sitting within the STIX node and its security framework can still interact on the same compute and store platform with a STIX-based node. What this then allows you to do is to manage these applications, different versions, different iterations, because from a STIX point of view, each node point of view, an application is just data. It's nothing different to the way we manage every other part of the data. So now what you see is you have the beginnings of being able to produce a secure military app store. And you have a way to manage that across your digital node network all the way from where it is manufactured and produced in unclassed land, all the way through to a protected or secure handset sitting out in an operational environment. By controlling the way this works and by managing the interfaces, this is completely doable. So let's talk about zero trust. I've mentioned it a number of times, and we've also talked about the need to be able to get these applications and this information across different areas and into the right environments. So how do we do that? Let's think about 7 layers. Security and control layers, and any individual one is not sufficient, but when combined, all 7 layers add up to zero trust required between the nodes and accreditation entirely feasible and possible. So layer 1, device transport SSL 1.2 with the appropriate crypto applicable to that transport layer. The boundary can be a custom firewall in the case of, or it can be OpenSense. So here we can have additional gateways and firewalls in addition to STIX's own protections. We can have crypto pairing between devices and the servers and the transport layers through the firewall. We can have custom crypto to each node. So think of a joint force scenario where traditionally you've had to go and create a common services hub to enable information to flow through a common services hub. And that has to be done quite frequently, either within the Five Eyes construct or within a single country to single country. And the diodes that sit between them increase in the cost and complexity of that. But if you could run separate crypto on each node, and there is no trust between those nodes, then you can now directly exchange information, and you can do it in a cyber-safe way. From a data exchange perspective, what you start to see is a primary information node exchanging with a secondary node. The data transfers are actually data fragments. Part of the STIX methodology is never to send the originating information across the wire or across the USB swivel chair process or across whatever bearer network is sitting between these two nodes. Data fragmentation means that even if you intercept the communication stream between these two nodes, the data in it, even if you break the crypto, will be meaningless. Therefore, you can run each node independently. This is done, and the zero trust is fundamentally enabled through the implementation of attribute-based access controls and claims. The combination of these, of separating the identity from the claims on the objects with which they're using them, and the labeling that you are enabled to be by those functions, enable you to set up your authentication and authorization separate to the crypto and the method of implementation. Each amendment, as we call it, which is the information passed across, still has inbuilt data non-repudiation and full data provenance. There is also the option of putting a Stargate device, the cross-domain solution, in between, which adds an even higher level of protection where that is necessary. The Stargate device, as I said, can be logical or physical, and it allows crypto pairing between the sender and receiver independent of the node itself. It also it can run across a diode, and it also has an inbuilt network guard, preventing from any network layer intrusion and attack. Inbuilt firewalls, treating both the T0 in this case and the T1 below, both sides are treated as hostile, and so no trust is created through the Stargate device either. The Stargate device and sticks fully supports data streaming and data forwarding. So the node boundary. The node itself is a security boundary for the purposes of securitization, management, and everything else. The firewall by default we would use is OpenSense, but we can also use Azure Front Door or any other mechanism required that can include intrusion detection, malware scanning, packet inspection, etc. There is a single entry-exit point being port 443. All the usual protections around MAC addresses to tie that port to particular places, along with the crypto between the different nodes, still exists. The gateway itself can be physical or virtual. So if you had a virtual gateway sitting in the between here, then you can have two cloud-based environments sitting between two different agencies and sharing across that virtual environment. If you are dealing with a federated mission networking or an MPE scenario, then that can be a physical device because it may be sitting between two different countries' implementations in a particular location. The next layer is critical, the authentication layer. Sticks can act as its own identity provider, or we can use any known identity provider. Active Directory, ADFS, Oracle, there are many. We do implement industry standards in the way that we authenticate and manage that authentication. So we are using SAML2 based tokens to enable these local trusts to exist. So the trust exists locally on this T0, and it is completely separate from any trust you have over here on the T1. What this allows us to do is to augment the information related to the user and augment the information related to the object we are securitizing, and we can augment that information from any data source. This might be your corporate directory. This might be your Active Directory. It might be another verified or trusted data source acting to provide identity attributes such as you see on the screen. So I may have attributes that describe my classification as restricted, secret, top secret. I may have releasability controls. These are dynamic attributes that are fully definable and changeable. I might have a caveat applied that is osteo. Technically, under the covers, we use this augmented information with the authentication directory to provide full zero trust implementation between these nodes. The authorization layer, again, SAML2 based claims. The user tokens are augmented at login with additional information. So we're not talking about an Active Directory login, we're talking about an Active Directory login augmented by these additional classification and securitization elements. What this allows us to do is to support both role-based access control or attribute-based access control, or both. The clear advantage for attribute-based access controls in the future is that securitization can then be done at any level, at any scale. A service account is used as the site owner account, and this works through both the UI, search, and all API calls to the data stores. Encryption. By default, we use AES 256 encryption. Where information is stored in SQL, we use transparent data encryption on the SQL boxes. Replication data files are encrypted using certificates, and the recommended hardware level of encryption or software level encryption. You can use your own custom-based hardware encryption if that's what you need in a particular operating circumstance. And again, as we've mentioned, port 443, TLS 1.2 and SAML 2 inter-service calls are also protected at TLS 1.2. Data replication plays a critical role in being able to fragment the data and therefore implement the zero trust concept between each of these nodes. User-based controls to approve content form part of the data replication, but can sit outside the node boundary. By controlling the way the replication functions, and by separating and not just doing straight copies of this information, but by using these pointers and data fragmentation methods in the amendment files, we minimize the risk of this information containing anything meaningful, even if it is intercepted by an adversary. Any process has to have controlled processes sitting within it. The user layer being able to approve information for release with a person or role in charge of actually releasing that information forms a fundamental part of the protections you have. Now, this can be a user, or it can be algorithms that allow certain controls and balances to be applied to this control and release of information. Once information is requested at the top node to be released, it can then be consumed and will automatically be ingested by the lower layer, and there are additional layers that can be applied at the lower layer as well. Applying this to a federated coalition information sharing set of scenarios and applying it to FMN, so Federated Mission Networking, so the European-based standards, STIX fully supports two nations operating across a low and a high side, with the left-hand side, in this case, a different country to Australia, sitting on the mainland with their own node network, exchanging information with their own handsets, to exchange information across the various different patterns defined within the FMN. So we support the hosted user pattern, we support the federation pattern, and we support the provider consumer pattern. The information exchange is fully secured, and each one of these simply represents a node and a digital node network within the definition of that we've been discussing today. But let's not forget management. How do you manage that digital node network? Just having the digital node network itself could be an absolute maintenance nightmare and make it unusable for a geek in the field. To do this, STIX has an advanced concept called schemas. Schemas, in the way that we define them, are technically implemented through XML, and what they allow us to do is apply multiple standards. They allow us to inherit Azure blueprints, which might be your data center definitions of how that works. And we augment that information within STIX schemas to allow you to define all definitional information, all content, all data schemas, all analytic schemas. Collectively, we are managing the data, the documents, and the training materials, all necessary to manage and maintain the platform layer. Remember the abstracted compute and store that you still need to manage, and the application layer. A concrete example. A STIX schema may distribute to a ship's intranet, version 1 or version 2 or whatever is necessary. That intranet might have standard operating procedures within it. of a particular version and are all at a particular level. In a land base, it might also distribute out a land-based intranet on how they want to function and how they want to operate. Standards, technical standards such as look and feel, all fully standardized, defined by the designers, accredited at back of house, security and cyber checked by CIOG or the security agency required, but used and implemented in this manner across the entire network. This transforms the whole way of trying to manage individual elements of a C4ISR set of applications. Currently, they're all attempted to be managed individually. Schemas allow you to manage sets of applications, data, and platforms as a consolidated, consistent way of handling that management function. Built into every node and built into the overall node network is audit and data provenance. Everything done in STIX is done to the UK accounting standards in full alignment with accreditation requirements. There are a number of anti-tamper controls and audit mechanisms that are built in, including alerting and controls off those. So what that means is that if we're managing platform layers and we want to harden an operating system, maybe it's a Linux operating system, maybe it's a BSD, maybe it's a Windows operating system, then from a central managed console through a schema, we can now roll out changes across the digital node network to the operating system in a cyber secure, protected way. It also means that as time evolves and applications are released, holes are always identified, bugs identified. These things can also be hardened by configuration, not by manual user builds of a particular implementation or a particular mission. By combining the schemas with the platform manager, this is how we implement complete platform management as code, all the way from the hypervisor, all the way through to the applications, the data, and the data distribution itself. Applying a full risk-based accreditation process, fundamentally, this is how you do it. This is published information, and STIX has been through this full set of controls, checks, and is currently awaiting final tick of approval. So in summary, what are we talking about and what is the homework question? The need. The need is to command through voice and control through data. Fundamentally, this has been let down in the past by the conversation being skewed to the network and the networking controls. And the concept of managing the data independent of the network has come fundamentally unglued, resulting in the military constantly having to dumb down what they're trying to do based on the network. The digital node network fundamentally addresses this and designs the data needs and the data processing controls independent of the network required for voice. We need to understand the power of data, and it's more than what we want to fire at. Controlling data, if you think about Google and Facebook and how they're using latent data to look for patterns of analysis, to look for threats in that way, and to be able to light those threats up in meaningful, usable ways at the pointy end of the stick, is fundamentally what STIX digital node network is providing. There are many who will say that traditional approaches to deployed operations have worked well. We disagree. We believe that you could do more of the same. That's what Kodak did. Kodak sat there and went, we are the photographic people. We don't need to think about digital cameras and digitization of our entire industry. Anyone remember Kodak? It didn't go well for them. We believe it's time to modernize. not just what we do when it comes to data, but also how we do it. And how can we solve a network issue without the network experts? Nothing that we've talked about today relies on the network in any way. It does not rely on particular routers. It does not rely on physical comms. And to do that, we have to think differently about what is the data problem and how do we do it regardless of the network in which we operate. And fundamentally, that's how we will move forward. So in summary, the digital node network. STIX platform leverages traditional technologies and has created a bunch of its own technologies, and it's leveraged emerging and new technologies to support legacy platforms whilst providing modern services. The digital node network fundamentally implements zero trust between the nodes, supporting the need for being able to operate as a military independent of other nations, but in joint force scenarios with information exchange occurring. Equally, it's no different from our design perspective to support nation-to-nation information exchange or agency-to-agency information exchange. STIX operates highly scalable services. These scalable services detect the platform upon which they're running, and they close and open services based on what it is able to run on where it is. STIX can operate on a smaller form factor that'll support force element of 5, all the way up to hundreds of thousands of users, and anywhere in between. So the digital node network is a fundamental rethink of how to use the technology to support warfighters in DDIL environments. And it's to give them the capabilities without them having to do the work themselves. How to light up the data, how to make it usable anywhere at any point in the network. I thank you very much for listening to me today. If you would like demonstrations or further information about STIX, how it works and all the fundamentals, then please just email the addresses at the bottom of the screen there. I will switch across now to questions. If anybody would like to ask, then please feel free.